All right, so we left off with stratified sampling. So again, that's what these blanks are. Gives you the title and then makes you write it again. But stratified sampling are basically to obtain by dividing the population into groups according to a characteristic important to the study, and then a random sample is taken from each group. So again, if we wanted to compare what I thought about the food at the high school, I could split y'all into grade level first, and then randomly choose a same amount of people out of each one of those groups. That's stratified. Put them into groups first, and then randomly take people out of those groups rather than taking you as a whole. Because then I can maybe get a little bit, make sure I had the a voice for every grade level. Because if I did you as a whole, I could randomly sampling could take like 20 seniors and like 2 freshmen, and then sophomores and juniors don't have a voice. So if we break them into groups first and then randomly select people out of that, then everyone at each group can have a voice. So in this case right here, it says a marketing firm samples a population by income level. The population is separated into 3 income categories: lower income, middle income, and upper income. The marketing firm then selects some subjects from the lower group, some from the middle income group, and some from the upper. So it just takes the same amount, typically the same amount from each group. If it doesn't, it's a little biased because it will lean towards one direction than the other. The next one is your cluster sampling, which, if you guessed it, the blank is very good. So to select a cluster sample, the population is also divided into groups, but these groups or clusters are intact or geographic groups. Once the groups are determined, a few groups are randomly selected, and everyone in the chosen groups becomes the subject. So once again, I could take y'all, split y'all up into grade level, 9th, 10th, 11th, and 12th, and then I would randomly choose the groups. So then I could then choose the voices of 9th and 12th and totally ignore the 10th and 11th. It would still be random, but now I'm randomizing the groups. So I pick a cluster. So stratified, I break you into groups, take the same amount of random out of each group. Cluster, I pick the clusters. Like I pick a random group or random groups. So I could do same concept. Maybe I want to know of the how the food is, but I want to do by hair color, by eye color, um, height, weight, whatever I wanted to do. And then from those, choose those groups completely. Maybe I just want to know people that are less than 5 feet, what they thought, people maybe that had blonde hair, what did they think? And then everyone else gets ignored. Right. But then you still try to randomize that per group. Like it would still randomly be chosen. All right. So here it says a school district wants to survey the opinions of elementary students. Clusters are the intact classes for each elementary school. Several clusters/classrooms are randomly selected, and all of the students in each of the classes chosen by the sample. So that's even better. I could, if I want to know about the food, and then I would group y'all up by your class that you're in, and then choose those clusters. So maybe I want Mr. Smith's room, and then Mr. Whiting's room. That was the random groups that I selected, and now you get to be the voice of the entire population. Okay. Again, the note here, the main difference between stratified sampling and cluster sampling is that although in both types of sampling, the population is divided into groups, the subject in the groups for stratified sampling are more or less homogeneous. That is, they have similar characteristics, while the subjects in clusters form miniature populations. That is, they vary in characteristics as does the larger population. For example, if a researcher wanted to use the freshman class as a university as the population, he or she might use a class of students in a freshman orientation class as a cluster sample. If the researchers were using a stratified sample, she or he would need to divide the students of the freshman class into groups according to major fields, gender, age, etc., or other samples from each group. Cluster samples are saves the researcher time and money, but the researcher must be aware that sometimes a cluster does not represent the population. So I like stratified because I get an opinion from everybody, or at least I make sure. Cluster can be maybe you get a classroom that's just so anti food in the school that you get a very negative response, but then the rest of the school was like, it's not that bad, but that one gets to dictate because that was how you randomly chose a group. What do you mean? Okay, yeah, okay, so yeah, so electoral will be more like stratified because now you're breaking us up by state and then rambling choosing people out of each state so that everybody gets a voice. But if I wanted to take a poll at how the Democratic Party does and I put y'all into states, but now I just pull Wisconsin, now it's going to be skewed towards the blue states or whatever the opinion might be of that. So that's what the difference is. Everybody gets a voice in stratified in their groups, but in cluster, only certain groups get a voice in whatever that statistics might be. And I still think that'd be more like stratified because your group, your vote would be more like an entire population, but it wouldn't be a random because it's everybody. We're taking the entire part of the population, not a sample, and then depending on where the majority falls, then we have selected amount of people per population out of that group. So like Texas, we have like 14 or something, but like Idaho has like 5 by population, but they still get a voice in it by population, but not maybe not so much big state versus small states, which is always the argument. Big states, if you look at it, don't have as much as a voice as small states do. The smaller states are heavy populated, where big states were really spread out. We got more acreage and less people. But I think of it like this: Cold Springs has probably the largest acreage of or miles for a school district in the state of Texas. But then look how many kids we actually have in the school district. We might be large by mass, but we have very small people living here. Not by height, just a small amount. Yes. Yeah. We're one of, I don't think we're the largest, but we're one of the largest areas. All right. The other one is which is what a lot of statisticians use, and it's called convenient sampling. And it's literally that. Convenient sampling is I want to take a poll of the food here, and I don't feel like going out to class. I'm just going to poll y'all, and y'all are my opinion now because y'all are convenient to me. So again, this would be convenience sample. So again, convenience samples are samples that consist of subjects that are available or easy to find. The sample is not random, the population is unknown, and the selection of subjects is haphazard. Results are biased or flawed, so this type of sampling is best for pilot studies. So a lot of times you'll see people like vendors and stuff that go places, they're randomly trying to just stop you on the street going, hey, do you have like 2 minutes of your time to do this survey? That's convenient. They're not going out looking for people. They're waiting for people to come to them and then going, hey, do the survey. And then we'll take a poll of this and see what this information tells us. That's convenience. So, and really and truly, you might not know what your entire population is. You might go, all right, well, 30 to 45 said this. yeah, we're going to go with this age group. And then we'll go, all right, this is what all 30 to 45-year-old are saying about whatever the topic might be, depending. And you might have gotten some results for people younger than 30 or than 45, but maybe very few. So that's where you're kind of pulling your sample from. So that's convenient sampling. So with that, now brings in sampling error. So samples are not perfect unless you literally take the entire population. So again, samples are not perfect representations of the population from which they are selected. Therefore, there is always some difference in the results. Other errors that exist in samples occur for other reasons. Right? So we could have a bias type of situation. Again, I go back to the political party. If I want something to look good for my party, I'm going to go poll where my party represents the most and say that the entire population thinks this. Right? All right. So definition of sampling error. So sampling error is the difference between the results attained from a sample and the results attained from the population from which the sample is selected. So basically, it's this whole idea between your theoretical and your experimental. You take a group of 20, you calculate some numbers, and you're like, hey, this is what my statistics says. And then you actually get the entire population. And you go, all right, theoretically, if 20 people said this is what population is. And then experimentally, if I take the entire population, this is what it actually says. So that's your sampling error right there. So a sample of full-time students indicates that 56% of the student body is female. However, the admission office states that of all full-time students, 54% are female. So the difference of 2% is due to a sampling error. So again, maybe we polled 100 people and 56 of them were females. So we're like, all right, so the entire body must be 56%. But then we go actually get the actual data, find out it's 54%. So it's not that we're wrong. We're just not exactly perfect. Yeah. All right, and then the next one is a non-sampling error. Non-sampling error occurs when the data are obtained erroneously or the sample is biased or non-representative. So again, this is a so sampling error. It's just maybe your sample wasn't large enough to represent your population, but non-sampling error is something on you. So it's again, I go to the political side. If I want something to be done for the Democrat or Republican side, I'm going to go to somewhere that heavy so I can get the results I want. But now that's a biased situation. If I really want to know the results of something, I have to pull. I can put it in a stratified group, but pull from each state rather than just one state I know is going to lean one direction. All right. So that's what, and this is this non-sampling error. This is what actually happens a lot of the time because we can avoid sampling error by just choosing a larger sample for our population. We can't avoid our opinion. And that's going to be real big here when we get into testing. Keep your opinion out. Just look at the numbers. You might lean towards a direction, but you got to just look at the numbers and say, these numbers say this, not I think it says this. This is what it says. This is what I can conclude from this. Just like we did in that first example that day. Yeah. Well, we called it something else though, didn't we? Don't remember it though, but I know we called it something else. All right, so here we go. So a researcher interviews subjects who enter the mall through a particular entrance to determine the reason for their visit. This sample is most likely not representative of general customers for several reasons, such as the sample was likely taken at a specific time of day when not all customers to the mall were shopping, and the sample was taken at a particular entrance through which all customers do not enter. Therefore, all customers to the mall did not have an equal chance of being selected. The difference between the sample and the population is due to what? Which one? Would it be a sampling error or a non-sampling error? non-sampling area. This right here is also known as a convenience sample. We're literally grabbing people at a door, not breaking them up into groups or randomizing anything. They were just convenient to us to take our survey. So this is a non-sampling error. Questions on that? Okay. So again, I told you this is a lot of words, not much math. All right, so let's get into today's topic, which is 1.4 observational and experimental studies. So again, observational is kind of what you see in a sample versus experimental, where you take the entire type of population. But here we go. So objective 6, we're going to explain the difference between observational and experimental studies. There are two typical types of statistical studies. They are observational and experimental. Love these vocabulary words in the title. So again, this would be observational and experimental. Observational studies, researchers observe what is happening. So in an observation, you're studying what is actually happening, or what has already happened in the past and draw conclusions based on the observations. So this goes back to that comic book thing. We looked in the past 3 years and saw the results that female comic book buyers was on the rise. But we solved that by going back and looking 3 years, going from where it was to where it is, and then we can draw a conclusion from that. But we can't just say, just because maybe you like comic books or you hate comic books, that women don't really like it or women really do. You got to look at the actual facts. Because if we would have saw the reverse of that and saw females going up, it could be the opposite. You could conclude, and I think Ella's the one that said it, that men is just going down in buying. So that's the two kind of results you can show from that with the actual evidence of what actually happened. But let's look at an example. So in example A, it says employees are rated as more competitive and less competitive. A researcher checks resting blood pressure and finds that more competitive employees have higher blood pressure. Right? This is an observational thing. This is not something that we're doing. We literally just go, all right, people are broken down into these categories. We checked every single one of their blood pressures, and we saw that more competitive people had higher blood pressure, probably higher stress levels, really what we conclude there. But we go with just what we saw with just observations. Does that make sense? Okay. All right, then we get into more of an experimental study. So, in an experimental study, the researcher can manipulate. Again. So, the researcher manipulates one of the variables of interest and tries to determine how that manipulation influences the other variables of interest. Almost like what I just did. I could say that most competitive have high blood pressure because they probably have high stress, right? That's a experimental observation that I'm kind of seeing from my observations. So in example B, it says a group of patients diagnosed with a particular condition are randomly assigned to two groups. One group is given a traditional treatment that has been moderately successful. The second group is given a new treatment that shows the possibility of being more successful. The doctors providing the treatment and the patients are not told which treatment they are being given. So at the end of the experiment, researchers will compare the two groups to determine if the group receiving the new treatment have better results. This is a true experimental study. This is actually called a blind sampling, where one group is blinded by what is actually given. They also have double blind as well. So what again? Yes. So a blind sampling here is, again, we put them into two groups, um, and they have no idea what treatment they're getting. So that's the first blind. A double blind would be if the nurse or doctor giving it also doesn't know. There's only one single person that knows what's an A and B, and everybody's blinded. Right? You ever seen that Grey's Anatomy one where she tries to switch it to give it to her dad? Yeah, so that's your experimental stuff. So again, that would be a true experimental study. In which the participants are assigned to groups randomly. And what that one little variable could be, it could be something like they're affected because this drug's hurting their liver. So here's another one that doesn't hurt the liver. Does this result change anything from that? I could say that, go back to the competitive thing. I could say that, you know, people are more competitive if they're surrounded with more competitive people, or less competitive, but then I would have two different groups with that. Put a competitive in there with a lot of more, and then one with less, and then see the results from that. That's just your experiment, changing one variable to really see what might be happening. All right, so then we jump into example C, and it says in one yoga class, participants were asked to hold a position known as a plank as long as possible during two classes per week for 4 weeks. In another similar yoga class, participants were asked to increase the length of time the position was held by 15 seconds each day. During the last class of the experiment, the average length of time of the 32 participants of the first group held the position was 4.5 minutes, while the average length of time for the 37 participants of the second group, who were asked to attempt to increase their time by 15 seconds each day, was 6.1 minutes. The conclusion was drawn that the group who were challenged to improve performed better. The researchers manipulated the variable of the type of instruction given to the participants. The yoga classes chosen were intact groups, so the researcher did not have the option of randomly assigning the class participants in each group, making the example what they call a quasi experimental study. That's a very good question. Quasis with a Q. That's about as far as I got. Yeah. All right. So let's go with quasi would be QUASI, and then experimental. So basically, what it's stating is for this to be an experimental study, that quasi part is the variable that was changed was a suggestion to the group. So a lot of times you can get people to be better by telling them that this is an advanced medicine that has 100% effectiveness, and then you give them a placebo, and now they're better from their headaches or better from their rash or whatever it might be. It's yeah, and it's basically that's all it is. It's just a mind thing where people really they have a lot of studies that really people are sick or they're depressed or whatever their emotions are or whatever their issues might be, could just be that they think they have it. So when you tell them like eat this broccoli and it has 100% success rate where you'll be as happy as a clam, and they eat it and they're all happy, but in results did the broccoli really do anything? Yeah. Yeah, and well, that goes back to this planking thing. If I just told you to do better on your test, you would just maybe study what maybe extra 10 minutes or something, and then maybe that'll be it. Maybe if you study 20 minutes, you study for 30 minutes and you just try to do better, and you might go up a point. But if I told you to study 1 hour more, challenge you to do that, then your retention of the material will stick longer and you'll probably increase your score by 10 or 15. So that's the difference between just asking you to do something versus suggesting something in helps of the same results. Yeah. 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 First test. Oh, yeah. Bring the pressure up. So, any questions on that type of experimental study or observational? So, observational was literally we did nothing, we just gave it, and this is what the result. Experimental, we changed one little thing to a different group to see, all right, was that one variable impactful or not? And you might find out too that you give a placebo to one group and then the treatment to the other and nothing happens. Like, right, well, that medicine's not working. Like, or maybe you suggesting something didn't work either. Like they still didn't want to hold it 15 seconds longer than the day before, or whatever the case might be. Because really and truly, you could state that, but those people in that other class could just been really motivated people, right? If I put in a whole bunch of depressed people in there, we might go, I'm not doing that. Or maybe not depressed, but maybe just defiant people into the room. You said 15 seconds, I'm gonna do 15 seconds less. At least that's what my kids do to me. So um, so just really it's hard to get a full study if you're not doing the full population. So just watch out for stuff like that. That's what I told myself too. All right, so we do have independent and dependent variables. They mean the same thing as what they meant back in the day. Independent variable is independent of themselves. A dependent variable depends on whatever that happened in that independent variable. So for instance, they were able to hold the plank longer because the independent variable was being asked to hold it longer. So therefore at the end they held it longer. So depended on how long they held it. All right. So here we go. So the variable being manipulated is called the independent variable. So it's the one thing we are changing to see if it is just that. Or the exploratory variable is the other big thing you'll see. Exploratory variable. Explanatory. There's an N. I don't know. Maybe I just so you say you're colorblind. Maybe I'm letter blind. I just don't see letters. Like the N just disappears when I look at it. It just disappears. I think there's a study I saw on Facebook. And I really can do it. It's like a whole bunch of it's a whole like paragraph almost. But it's the first letter, the last letter, everything else is like random letters. But I can read that whole thing because that's literally what my brain does. I catch the first, catch the last, and it makes up the middle. So I don't know. The variable or variables being measured or the resultant variable, that's another key word, are called the dependent or outcome variables or outcome. So again, in this situation with the thing being told or something like that, that's the independent one single thing that's being changed, and then the results of all that is all your dependency. Like they actually held it longer because I said this one thing. And that's the one thing that's being changed. Questions on independent or dependent variables? Any questions on vocabulary? I know it's very vocabulary heavy, but this is kind of where we're at. Yes. Um, I gotta do a quick study on the population of eye color. Green, blue, purple, yeah. Okay, cool. There's my study, and I'm done. Haphazard's like real quick and dirty. Like it wasn't thought it that if you replace that last what's the words called? The suffix to another term word. That's basically what that is. You have, yeah, yeah, yeah. There was no thought process through it. You were just like, I want to do a study. I'm in a group of 100 people. And I'm just gonna whoever's willing to answer my question. It wasn't thought out, and then that's why the population's kind of unknown because you really do the study and then you're like, looks like this was my majority. That's my population, so that's what I'm gonna go with. So it could have been for the entire population of people. It could be an age group. It could just be a location thing. You just really don't know until after the study. Good question, though. River's good answer. I can't say that. All right, so in example B, the independent variable is the treatment given to the groups of patients. Tried my best to fit it in. So again, going back to example B, that was the situation with the diagnosis where they had two different groups and one group got something and another group got a newer version. So the independent part was the treatment that was given. First group got the older treatment, other group got the newer treatment. And so therefore the dependent variable is whatever the response of the patients got from the treatment. So however you want to kind of write that out. But they have here the response of the patients to the treatment, or you could have added in, which is just the medical results. So whatever, however they resulted from the old treatment and the new treatment, really kind of just determined if the new treatment was worth trying or if the old treatment was good to go. Example C was the yoga class. This was the planking. So what was the independent variable? Okay, like that little extra sentence there. Perfect. So they went with instructions given, but yes, with that little extra motivator to go 15 seconds longer. What would then be the dependent variable? What was the result of that? Very good. So the amount of time they were actually able to do it in 4 weeks. Very good. So, and they went with the length of time participants were able to hold the plank position. Given. Should you put a G at the end? Okay. Have I told you I don't take off for spelling? Yeah. Okay. Cool. So, any questions on how to determine the independent and dependent variables? So, independence, the one thing that gets changed, dependence, the result from it. Again, and aging was my biggest issue. If I wanted to say again, I spelt out aging. Mm-hmm. And so I did that to one of my teachers, and they're like, I feel like you're insulting me by asking how I'm aging. And I was trying to ask, like, I've given or something like that. So, or not again, sorry, again. I was asking again what was something. But, anyways, different story. All right, so treatment and control groups. This is like your placebo thing you were talking about earlier. So, in an experimental study, the group of which the independent variable receives manipulation is called the treatment. All right, so they are the treatment group. And the group of which the independent variable is not manipulated is called the control group. So, when you're trying to determine if something is really changing the results, you'll have one group that you change that one independent thing, and you'll have another group where you change nothing. All right. So that's kind of like your planking thing. I changed nothing. They still had to do the work, but in my treatment group, I said this one thing. Did that help or not? All right. You don't want to change two independent things because you're not going to get a good result. So you don't want to say something positive here, then go, well, I think if I say something negative here, we'll get different results. You change one thing at a time, one worst control, so you can see the results. If you want to see if saying something negative happens, then you do a whole nother experimental study where you say, I bet you can't do it for 15 more seconds, or something negative or something like that, versus like another control group. Okay. So, advantages and disadvantages of experimental studies. Advantages, participants can be assigned randomly to the treatment and control groups. The independent variable can be manipulated. So, you can still randomize it pretty good. Disadvantages, they often occur in laboratories or special classrooms rather than in natural settings. So maybe you'll have better results if you did this at a park. If you gave treatment because the sun was shining or it was a pretty full day, or you could hear the birds chirping or whatever. That could be like a disadvantage there. Um, then they have what they call the Hawthorne effect, which is just a phenomenon that occurs when patients' behavior changes because they are involved in an experimental study may occur. So just because you're in an experimental study, your elevations of stress or blood pressures already elevated, and so that it might cause a reaction to whatever the treatment is as well. Yeah, so like you would literally have to be like, "Hey, try this piece of chocolate," and tell them nothing about it. Just like you're in your happy area and you're just telling them to try things, and then you're studying them. Oh, your hair's green now. Okay, cool. We'll put that in there. Now your skin's a little orange. You're shrinking a little bit. Yeah, you caught on. Cool, cool, cool. So that would be the Hawthorne phenomenon. All right, so a variable known as a confounding variable. So confounding. You also might see it as lurking. These variables that is not being studied, recorded, or manipulated may actually influence the outcome of the dependent variable. So if I take something away as the independent part, and then I get these results, it couldn't be maybe not that absence, but it could be something else. Maybe they ate something before they came in that's causing these results. Maybe the fact that there was a fruit stand outside their door, so they all grabbed some fruit, went in there, took the treatment. These did not. Results looked really good, but it might have nothing to do with your actual treatment and the fact that they all had fruit for breakfast or something like that. Right. So there's always those lurking or confounding variables that are unseen. We didn't change it intentionally, but something did change in both groups that we didn't see. Yes, now you're catching on. You got to do like a study for a year and watch their every commands and walks and go, all right, now go and take them in and just kidnap them for another year so you can control their habits for a year and then bring them back out into the world. It's what aliens do, right? They take you up and they really want to get a good study of you. All right. So, any questions on that? All right. Two, what do you mean? Alien things? No. I am not going to assign an assignment where you have to be a stalker. I feel like my job here would be very limited at that point. Might do something like that. We'll see. We'll see. All right. So, advantages and disadvantages of observational studies. Advantages, the study occurs in a natural setting. Observational, we're literally just observing what they're doing naturally. So again, when we looked at the competitive and saw their blood pressures increase and decrease, it was in their own natural setting of their competitive sport or competitive academics or just competitive of how long you can sleep in a day, like whatever your competition is there. This type of study can be used when it would be unethical or dangerous to manipulate the independent variable. So if I wanted to find out like something about your blood pressure or something, and I wanted to rise it, that kind of could be a little dangerous to see if it has anything to do with your competitive side, because then I could put you in cardiac arrest and now I've killed you. So instead, I just have you in your natural setting doing your own thing. So if it rises too much, it's on you for being too competitive. I was just observing. Right? So that's kind of like you're unethical or dangerous. Like, I don't want to change something that affects your actual death or nothing, but if it naturally happens, it's no longer on me. It's just part of the study that I was observing. Right. So, like those stress studies you have to do at the hospital and stuff. All right. So, there we go. So, then variables that cannot be manipulated, such as ethnicity or left or right handedness, can be studied. So things that cannot be changed or manipulated, like if you're white, I can't make you not white anymore. If you're left-handed, I can't force to make you right-handed. That'd just be what's it called, ambidextrous or whatever. So things that I can't change, I don't have to change. Yes. Well, then that's just teaching them at that point. Di- Disadvantages, cause and effect cannot be shown. Studies may be expensive, or time consuming. So this could take years for me to show the results on something in a natural habitat that I'm just waiting for something to happen. Like if I'm seeing that more competitive people have high blood pressure, I might be wanting to know, does it cause to a cardiac arrest? And I might have to wait a few years before someone finally drops down. So it can get expensive because I'm also getting paid to watch people get really stressed out. It is, it can be. So again, results are subject to inaccuracies due to dependence on those who collect the data as well. Right? Any questions on observational things? You possibly could. It could all be undercovered. All right. Keep in mind, though, that two different studies regarding the same independent and dependent variables may result in different or conflicting results. So we literally could be doing the same treatment study here, and then someone could be doing it maybe up in New York, and our results could be different. But that's going to be coming from your confounding or lurking variables that we don't see. Could be a colder day when they went up there. Could be a really hot day and you're flustered coming in. Your blood pressure's already a little high. It also could be the way we eat versus them, what we're eating as our diet. We eat lots of tacos. They probably eat like a lot of nuts or trail mix or something or whatever it is. But it could, so a lot of other different variables could cause different or conflicting results. We could see that yes, more competitive people have higher blood pressure down here, but we're up north where maybe they're not very competitive to begin with. More competitive people could have less high blood pressure. Right? So that says different results in different areas on things that we can't really control. Which then leads us into objective 7, which is explaining how statistics can be used and misused. But hold on, I feel like that's for tomorrow. So let me start going further. Oh, no, okay. Yeah, so I feel like that's about it because this right here ain't going to take long. All right, so we'll actually stop here and pick up tomorrow. This will be a great time to work on your chapter 1 homework. There's only uses and misuses of statistics left, and that is